about us, what we do, what we do. And Pioneer Business Solution, we are a leading corporate learning partner across the globe, and we have many successful stories, and we are well known in the market for all the niche technologies and customized training, and meeting the client expectation as per their need. And we are and I would like to give these are our IT training competencies like data science, mobile and web technologies, cloud computing, AI, ML, BP, RPA, big data, database, networking, automation, and DevOps. And this is all our soft skill training competencies. So where we'll be doing all business skills. This trainings will be giving from the fresher level to a expert level. And this trainings, all soft skill training, also can be customized as per the business expectation. So majorly on the design thinking and stress management, conflict management, and emotional intelligence. So we can connect with the trainer, and based on the client expectation, we can meet the 100% support on the quality basis also. And this is all our delivery modes like instructor lead classroom training, virtual instructor lead training, and hybrid learning and e-learning, mentor on demand, and open house session. In open house session, we can we it will be not considered as a batch, so we can do a minimum 3 to 5 participants also, and it will be very cost effective. For more details, you can reach us. We can give you in-depth presentation on this slides. So this all are major clients which we are working from day one to this, and we have many successful stories with these clients. These all are major clients, and recently we have delivered extrovert training for international clients also, and we got very positive and feedbacks also with this. So this is all about us. So I would like to welcome. Glad. Okay. We are glad to have Shivang with us today webinar. So I would I would like to give you one small introduction about Shivang. Shivang is an senior AI consultant and corporate training. He is an IITN, and he has more passion and pattern on computer vision, and have successfully lead many AI projects, and for all the across the globe. And he worked with many clients like IBM, Cyan, and Unisys, TCS, Deloitte, FCC, and Quad, etc. And today's topic is all about the deep learning distribution across industry. What will be the future challenge and opportunities, and cross domain challenging adoption, implementation strategies, open source, and hard deep learning modules, solid learning path for beginners, how we can help. So this is all for topic today to discuss. And For any questions, please drop a text in the chat box. Shivang will be answered once we completed this webinar. And thank you. Before wasting the time, let's dive into the webinar. Over to you, Shivang. Thank you all once again for joining.
Yes, so I'm sharing my screen. Let me know when you can see my screen.
Sure, Shivang.
Is my screen visible to you?
Yes.
Am I visible to you? Okay. Hi everyone.
Yes.
This is Shivang Trivedi. Uh, uh, Thank you, Sugandhi, for my introduction. Uh, at the very core, I'm a learner of artificial intelligence. This is a big field, and it would take an entire lifetime to actually understand things around it. So I'm a very humble learner of this subject. Yes, I've done some of my work over here. I have a patent on computer vision in the United States. I've been into corporate trainings. I've been into training people. I believe that education and training is something that is very necessary to transform the country. If we really want to make our country developed by 2047, if that's the dream of our prime minister and the current government, and if that's the esteem of today's India, It's just not about artificial intelligence, but entire education has to be transformed in a way. And I, from my side, want to pay some contribution in that perspective. So from the core, I am a trainer, I'm a teacher, I am a passionate teacher, I would like to do that. So that I'm a consultant too. That's what I've been doing for a very long time, building technologies for different clients, some for myself and some for other businesses. So today's discussion is like this: transforming businesses with artificial intelligence. Uh, what exactly is AI? We will try to understand slightly from a technical perspective too, so that it acts like uh, don't look like a black box to us. We will make sure that at the end of the day, all you guys will understand that this is not something which is magical and quite effective. Somebody who knows a few things can implement it. We'll also discuss about the current industry trends, what's going on, why it is necessary, why it is the right time. uh, we'll also discuss about the technologies uh, which we are using in our daily life, and how this thing can be a one-stop solution for many problems. We'll see the future, very near future. By future, I'm not trying to say about future far ahead, but the future far before we reach our retirement. I mean, most of us reach our retirement, that kind of future, and how uh, within a few years down the line, the world is going to change completely because of the way technology is going ahead. We'll also look into the cross adaptive learning, some of my thoughts over there, what needs to be done, why it is very necessary for organizations to do that, how we can do that. And I'll also share some learning resources. These resources are things that I have gone through for my own study for years, and this may act as a learning path for somebody who is a self learner. Yeah, I'll also at the end of the day would commit that yes, a coach is somebody who will be really helpful. For example, Kohli is a very good player, or any good athlete. Maybe Messi is a great player, but still there is need of a trainer, there is need of a coach. So we need to understand how education and human mind work. So from that perspective, let's start this very boring and pathetic session on artificial intelligence. I'll make sure that it don't go like that, and I'll make sure that the audience stays connected and you guys like it. So let's start from the technical perspectives. So if we talk about artificial intelligence, we know that artificial is a very straightforward thing, correct? Which is not natural. Intelligence is more philosophical. Now, how would you consider something intelligent? How would you, first of all, uh, is it that intelligence is only a property of living beings, or intelligence is a fundamental construct of this nature? So that's an interesting thing. So we can consider like intelligence is something, some traits, like if a system is able to learn over the period of time, if a system is able to make some decisions, if a system has some kind of cognitive abilities, so and so and so, and then we can consider it intelligence. I would consider that intelligence, artificial intelligence, is a philosophy, and there are 6 scientific tools and techniques to implement those philosophies. I mean, there can be many, but broadly we can consider there are like 6 sciences to implement this philosophy of how we can build technology as smart or far smarter than human beings. One of them is machine learning, that we are going to discuss in this session. Another is game theory, Markov decisions and game theory, the game playing. If somebody remembers these Deep Blue in 1962, IBM was able to make a supercomputer at that time in 1960s, in the time of Cold War, where computers were able to defeat Giri Kasparov, the grandmaster of chess at that time, and even for a very long time. Knowledge representation, this is something which is already there in market. If somebody knows about Prolog, people use this, and it has its own quite uh, of benefits and advantages. Deep learning, the topic that we are going to discuss, factor graphs and Bayesian networks, all kind of complicated things related over there, and combinatorics, combinatorial optimization problems, which basically is used in most of the times they are used in graph problems. For example, how Google Maps find out the shortest route between source and destination. It's considering all the parameters of traffic and multiple route possibilities and routing, and whether you are walking or going through a car or by bike, or like season, weather, time, duration, everything. And using all those permutations and combinations, Google Map try to find out the most optimal way, combinatorics. Many strategies and algorithms to implement these. So we can consider that these are 6 broad categories of implementing artificial intelligence. There may be more, but largely speaking, we can cover the entire subject into these 6 focus areas. Now, this is there in market since 1950s, 1960s, since the Cold War era. If you remember something called a Turing test. Uh, if Turing test is something that we will not discuss right now, but basically Alan Turing, the one who created, gave the paper of the first universal Turing machine over which computers were created. So AI is quite an old thing. But suddenly after 2012, especially after 2012, this research paper by Professor Jeffrey Hinton from University of Toronto uh, gave a big breakthrough. And after that, we were able to train deep neural networks sufficiently well. So this thing in 2012 is considered like a big breakthrough. And then suddenly in next 8-10 years, we see artificial intelligence and machine learning and deep learning all around the time. So there happened something because of which there was a sudden boom. Before that, we considered that it was kind of a dark age of deep learning. So that's what we need to understand, that it's a quite weird thing for computers. The things which are super hard for human beings is very easy for computers to do. But the things which are super easy for human beings were very difficult for computers to do. And because of this paradox, there were so many real world problems that we were not able to solve. For example, it is really difficult for us to play chess at grandmasters level. It is very difficult for us to defeat uh, Carlson or like Vishwanathan Anand or like Gary Kasparov. But computers can do it quite effectively, and we were able to build such AI systems that can defeat best of the best minds on the planet in this game of chess. But we were not able to build small software for a very long time, which with great accuracy can classify whether there is a burger or a pizza, whether there's a burger or a sandwich, or whether there is a dog or a cat in the image. So a 5-year-old innocent boy can actually look into a photograph and say that this is a burger and this is not a burger, or he can recognize her mother's face. So kind of things which very small guys, very small kids can do almost fluently. Understanding the language, so many things that our brain can do very effectively, and we take these things as granted, but these turn out to be extremely daunting challenges, very difficult tasks for computers to do, and very difficult for us to build programs or technology around this. Because of that, because of this very nature of technology, that it is able to do things which were hard for human beings quite easily, and it was not able to do things which were very easy for human beings, created a lot of problems where we were not able to use artificial intelligence as of now. By this breakthrough in deep learning, we are able to solve this. So that's why this buzz is all around, and this is the new thing in the market. Quite old now, like there's been a lot of work going on. But yes, this is a breakthrough, and most of the state of the art technology that we see today is because of this beautiful revolution that happened in last decade. So our agenda is what is going to be this upcoming decade, what would be the next 7 years of technology that we want to establish from a business perspective. But to actually understand, let's first get into what exactly we are doing. Again, just like we don't need to learn mechanical engineering to drive a car, we don't need to understand how engine work to actually become a great driver. We also don't need to understand, at least at beginners level, we don't need to understand the very fundamentals of artificial intelligence and machine learning and all to actually start into this field and build some technology. Over the period of time, yes, you need it, but it's not like you need to be super mathematical in nature to do so. But just for the sake of opening the hood of the car and understand how a car works, we are going to look into some technical details of what artificial intelligence, what machine learning, and what specifically deep learning is. Uh, if there are some people who are not from maths background, next 5-6 slides may be something that be difficult for you, although I've tried my level best to simplify things. But again, that's not a prerequisite. That's just something that we are doing for the sake of science, to have some kind of a general understanding of what's going on. Now, let's talk about machine learning first of all. Before understanding deep learning, let's get into machine learning and see what's happening over there. So, there's so many things which computers can solve that easily. The reason being, we as human beings are not able to build good programs. So if you come it down here, and all the other circles that you see other than machine learning and deep learning, they are high end. Just 1 second, guys. Just 1 second. They are high end technologies, like uh, very sophisticated technology that we as human beings have written the programs. And as human beings, all computers are doing, like basically following the instructions. They simply execute a program which is nothing but a few lines of instructions that a computer can follow, and computer can follow those instructions million times. So building a chess engine is kind of mathematical. There is an algorithm called min-max algorithm, and then you use something called Monte Carlo simulations and pruning and all kind of things to build a recursive algorithm created by some developer, and that's it. Now computer will follow that algorithm step by step, and do it. Consider it like this. There is a guy uh, who solved Rubik cubes in 10 seconds. Like, let's suppose that you try to solve a Rubik cubes, you would find out that this is very difficult to actually find out the entire solution of a Rubik cubes. Most of us will not be able to do it. uh, if we give real hard time, it will take even hours, 5-6 hours for us, or 8 hours for us, maybe a week, to actually get the solution if we are really really hardworking and really intelligent over there. But then you see there are people who solve a Rubik cubes in seconds. So what you can do is you can actually go to YouTube and understand how to solve Rubik's cube. You understand the entire procedure and simply follow the procedure step by step, and then you will be able to solve it. If you remember that, you will be able to solve that Rubik cubes very fast. uh, Computers can follow instructions very fast, but if you consider, what would you consider more intelligent? The person who has somehow understood the procedure of solving a Rubik's cube, and he or she continuously follows the instruction to reach out to a solution? Will that person be more intelligent, or somebody who by himself have found out the procedure, even if he have taken like 5, 6, 8 hours to come to the solution? We would say that the second one is more intelligent, and simply following the instruction is something that we cannot use. In the same sense, all the other circles are basically human written programs, but there are so many programs that we just can't write. For example, just 1 second, guys. Just 1 second. Yeah, guys. So, for example, I give you a case of something that you use every day. That is, you all use Gmail, and you all get a lot of spam emails and regular emails. And then these developers in Google want to create a functionality so that the spam email goes to spam folder and good email go to the right folder, your inbox. But it's not that straightforward. Something which is a spam for me may not be a spam for you. For example, let's suppose that I'm planning to buy a new car. I'm planning to buy a new BMW. And in that case, if I get a lot of emails related to BMW, I may be very much interested to know and explore more about it. Let's suppose that you have already bought a car and you are no more interested in buying a new car, and suddenly you get multiple emails related to car advertisements or like car specifications. It would be kind of a spammy for you, because those emails are of no relevance to you, and it would seem like somebody is doing email marketing and it's not something that you are interested in, and you will consider them like spam. You don't want to see them in your email. So some kind of email for me at a particular time can be something which should go in inbox, and the same kind of email for somebody else at a particular time may be spam. Then there are a few emails which are spam for everybody, most of these lottery frauds and all kind of things. And now, how would you figure out whether that email is fraud or not? It depends on a lot of things. It depends on the content of the email, how the person has written the same content. I can write the same thing in multiple languages. So there are so many permutations and combinations involved. For example, one word can have multiple meanings. For example, I was sitting near the bank of a river, or we should have a big blood bank, or I recently visited a bank to get some money. So I'm using the same word bank multiple times, but for three sentences, they have different meanings. I can say the same information. I can give you the same information in different sentences. For example, my name is Shivang Trivedi. You got some information. I can also say that my sister have only one brother, and his name is Shivang Trivedi. I have used completely different sets of words, but you get the exact same information. Now, consider all these things: the email routing with the domain specificity, how effective or like what is the domain authority over there, the user preferences, the user behaviors, what kind of emails user considered spam a few days back, the content of the email and everything creates so many permutations and combinations that it is not possible for us to write down a spam classification procedure step by step, just like we write a chess engine to do that. That's why howsoever smart developers can be, they cannot write a program which have so many permutations and combinations where we ourselves don't understand the entire problem correctly. In such a case, there is so much randomness in the process, and the problem cannot be defined mathematically. The problem is defined statistically. It is a statistical problem because there is randomness involved into it. A queen is a queen, a position is a position. In chess, there is no ambiguity over there. In such a way, spam classification is something that we cannot write down a rule based procedure for. If you find out, there are so many real world business problems related to economics, finance, supply chain management, demand forecasting, computer vision, natural language processing, voice assistance, self driven cars, forecasting, medical science, drug discovery, human DNA, so many things, defense industries, where there are so many permutations and combinations and so many ambiguity and so much randomness. So that's where the thought comes: can we build such technology that can evolve or that can learn over feedback, which can learn over the period of time? So can we do that? That's the main philosophy, or that's the main objective of machine learning. Can we build an okay program for now which can improve over the period of time? So, like Google has deployed a basic spam classification feature in Gmail. And when you get an email, you tell it to Google that this is a spam for me. And with that feedback, Google keep on, or Gmail keep on understanding your priorities, and it becomes better. Just like Instagram or YouTube, where they show you some videos, but on the basis of your feedback, your watch time, your comments, your engagement to the video, your click through rate, your likes, your dislikes, the people similar to you who have watched those videos, YouTube's get the feedback and it learns over the period of time. Instagram gets some feedbacks and learns over the period of time and recommends you the videos. Similarly, you tag your friends on Facebook, and over the period of time, Facebook starts to give a suggestion that okay, this is the same person. So this is Ramesh and this is Suresh. So kind of Facebook learns the faces of the people, your friend list, over the period of time. So here, there is not one shot solution, but the systems are learning over the period of time. That is the crux of, that is the main idea behind machine learning. That's the main philosophy. Now, how do we implement this philosophy? That's what we need to understand. Okay, so this, uh, what in general happened so far now is there is a programmer who write the program. Once you have this program, which is written by a programmer, a chess engine or something like this, we give input and the program give us some output. So you write the program, you give some input, you get some output. In machine learning, at least in some kind of machine learning, which is called supervised machine learning, we don't write this program. We write these learning algorithms, these machine learning algorithms. And we give a lot of training data to these machine learning algorithms. These training data, basically it means we are giving a lot of input and output. So for this input, this is the output. For this input, this is the output. Now what is the program? So in general, computer sciences, this is the program, this is the input, what is the output? In machine learning, it is like, this is the input, this is the output, what is the program? That is, just 1 second. Just guys, 1 second, my parents are leaving home. So I'll just uh, pause this for 30 seconds and come back. Pardon me. So my parents visited, so I just needed 1 minute. I'll go back to what we were discussing. So classical computer science, this is the program, this is the input, what is the output? Machine learning or supervised machine learning, this is the output, this is the input, this is the output, what is the program? So that's the core idea behind it. This model is exactly not program. This model is basically some kind of a matrix, some kind of a tensor, some kind of a representation of input and output. So I'm just saying it as a program because I want you to understand. I just don't want to confuse you over there. But this is kind of the work of a model is nothing but the program. But this is moreover some kind of a high dimensional metric. It is basically collection of a lot of numbers. You can consider a model is like some kind of an Excel sheet or multiple Excel sheets. Consider it like this, but the core functionality is it acts like a program. Now let us build something. uh, let us build a program that can classify different birds. I mean, let us try to build a program from a conceptual perspective which can classify which bird is in this image. So this is my favorite, so that's an eagle. But this next photograph, this can be another bird, and this can be another bird, this can be another bird. I think there is like, this can be another bird, this can be another photograph, next photograph. So there are so many photographs over there, and our goal is to write down a program so that we give an image as an input, we want output. Now you see that in every photograph that you see, there is some background. The background is some data which we don't need, which acts as no information to us. So in this photograph we have a noise which is the background, which is of no use to us, and then the pixels which are related to the bird is something. Now in this photograph you see that this bird is sitting on some tree, and the pixel value of this image is also the data, but that is of no use to us. That's data, that's randomness, not the exact information. So there is randomness, there is a noise in the data, there is information in the data, and we need to come up with some solution. So how do we approach to this problem? If we give this image as an input, how do we classify which bird is this? An eagle, is this a peacock, is this a flamingo? So if we simplify the problem, we would see, now this is where it becomes interesting. If we simplify the problem, we can say that there are a few things that may be important to us. For example, color of a bird can be something that is a factor of consideration. Wingspan can be something of consideration. Size can be something of consideration. And then there can be so many x1, x2, x3s, so many factors, so many features which are of consideration to us. Now if you see, all these factors will put some weight on our decision. If the wingspan is really large, it may be an eagle. If the color is blue, it may be something else. If the size is small, it may be something else. So it is putting some weightage. It can also put a negative weightage to something, or like all kind of numbers it can be there. Now, even the color and the size and the wingspan and everything we are going to represent as numbers. So we can say that black can be considered as 1, red can be considered as 2, blue can be considered as 3. Or we can also come and say that red can be considered as 0, 1, black can be considered as 1, 0, green can be considered as 0, 0. So we can also convert them into binary or something like this, or basic numbers. Everything is represented in numbers, and then there are some weights associated to this. Now these weights and these numbers create some kind of lines for us. So what we are saying is, if this is, these dots represents our data x1, x2, x3, x4 right now, because it is in 2 dimensions, so I'm only plotting, I'm only showing you x1 and x2. So if this is the data, if x1 is the wingspan and x2 is the size of the bird, then we can come up with these three lines. And if a data point lies to one side of the line, it may belong to eagle. If it belongs to some other segment of this vector space, this xy vector space, it may be something else. Or if this belongs to some other set, it may be something else. So all model is doing right now in this simple example is to find out the equation of the lines. What is the exact equation? Mx plus b, y is equals to mx plus b, or something like that. This can go really complicated, because we know that x1 and x2 size and wingspan are not the only problem. If you look into this image, there may be other factors too. There may be 10, 15, 20 factors if you understand the problem correctly. uh, then there may be a lot of things, and you must appreciate that it's not that easy. There may be a small eagle and big flamingo, so it's not that straightforward to say that, okay, if something is small, it is a peacock. I mean, if something is small, it is a parrot. If something is large, it is a peacock. There can be a big parrot sitting far away, or there can be a big peacock sitting far away in the image, and then there can be a very small, tiny bird sitting near to the image, near to the camera. So it can cover a bigger size. So there are so many things that we need to take care of. But if we consider them, this uh, can become slightly complicated. For example, in this diagram, now your data is represented in 3 dimensions. It can be like your color, size, and wingspan. Now I cannot represent you, I cannot show you 4 dimensions, I cannot show you 5 dimensions, because that's something that we cannot visualize. But if we simply represent the data in 3 dimension, then this plane surface is the model which is classifying. If it belongs to one side of the data, it may be a eagle. If it is on one side of the data, it may be a flamingo. Now this can be non-linear too, interestingly. Not necessarily that we can find a very linear geometry, very straightforward thing. This can be non-linear too, and this can be 50 dimensions, 500 dimensions, 5000 dimensions. So you understand that you have a lot of data, and then you don't know how to visualize it, and it can be non-linear symmetry. How do you find out that curve? How do you find out the decision boundary which can classify things? But for the sake of simplification, we are considering for now that this is a plain thing. In much more technical perspective, we are making an assumption that a linear machine learning model is sufficient enough to classify things. But let's not get into the technical jargon. Now, how do we find out this? How do we find out this plane? So first of all, we need to make a prediction. And the way we need to make a prediction is we figure out whether it is going to be a straight line, or it is going to be a plane, or it is going to be a hyperplane. In easy language, we'll find out what exactly is the model. And then we don't know the weightage, we don't know the exact permutations and combinations of these features. What is the weight of that feature, how it is behaving, how it is contributing to the actual decision that we want to make. So we put all these weights at some random numbers. So if we start with some random numbers and we make some predictions, all our predictions are going to be completely wrong. We will have a lot of error, we will have a lot of cost. And this cost is because we started from a random position. So we update these weights, we do something so that these weights become slightly better, and our predictions becomes better and better over the period of time. It's like when you're on a radio and you want to listen to a good Hindi song or a good English song, you don't know what exactly is the frequency on which that music is streaming. So start from some random position of these radio, you move it here and there, eventually you reach to the right position. In this case, we don't move it here and there, we use some procedure to reach out to the right position, but basically this is all setting the right frequency of your radio so that you can listen to the good sound. That's what we are doing. So I'll take a very simple example of a linear model to explain you the concept. So this y is your prediction, b0 plus b1 x1 plus b2 x2 and so on. There are some numbers which we are adding, some numbers which we are multiplying. All the b's are the coefficients, all the b's are the weights, the impact of that feature on our decision, and all the x's are the features itself. So x1 can be shape, x2 can be wingspan, x3 can be beak size, beak type, where b0 b1 can be some factor of what exactly is the factor of wingspan impacting the decision. So this equation b0 plus b1 x1 plus b2 x2 is basically a linear combination of input features, because we are doing nothing but multiplication and addition. So that's why it can represent a straight line or it can represent a straight surface, a straight surface. Now we want to find out to which side it belongs to, whether it belongs to left or whether it belongs to right. If it is far away, we will associate some kind of probability. If it is near to the surface, we associate some kind of probability. For example, if a dot is very far away from the surface that we have figured out, then we are very, it is highly likely that it belongs to one category. Where if a data point lies exactly on the surface, then we must say that there is a 50-50% chance it may belong to anything because it is exactly on the surface. So this numbers, additions and subtractions of a few numbers, we put it into some kind of a formula called a sigmoid function, which gives us the probability. We don't need to get into it. I'm just trying to open the engine and tell you how a car works. But while actually driving the car, we don't need to get into it for now, because we consider that a lot of non-technical people will be there. So I don't want to get into the jargon. So we do something, we use some kind of mathematical formulas. We have some mathematical assumptions to generate some kind of a probability. But if you understand this thing, you understand what is in the heart of machine learning. It is a very scientific, effective way. There is no uh, magical learning as such. This is science. Once you decode the magic, it becomes science. So there is no as such uh, magical intelligence or the computers are becoming super intelligent. The impact of this, which we are going to discuss when we understand neural networks, the impact of what we are building on actually makes computers quite intelligent. And what we are going to understand in a few slides, we will understand that intelligence itself is not a human construct, which is our wrong thought. Intelligence is a mathematical property of universe. So it is a mathematical property of universe. That's what we will try to understand, that it can be done in that way. It's my belief. That's not. That's a hypothesis which we need to prove. That's my spiritual aspect of artificial intelligence that I have understood over the period of time. Now again, you start from some random position and you make some model. So this is what your model is basically. You calculate this y, and then you put it into this formula and you get some probability. So this is one kind of a model. This can be considered as a linear classifier model. There are so many things. There can be a decision tree, there can be a neural network, there can be a support vector machine, there can be a GPT that is going on market, chat GPT, there can be a large convolutional neural network, there is an algorithm called XGBoost, there is an algorithm called linear regression, there is something that is known as maybe hierarchical clustering, or like it may be a technique called principal components analysis. There are so many different techniques. One of the technique is a linear classification. What we are doing, we are calculating y by multiplying our input features with some numbers, some weights, and some coefficients, the impact, which we don't know, and then we put into this formula and we get some probability. Because we don't know these numbers, all these b0s, b1s, and bn are randomly initiated. Because of this diagram, we initialize our weights or our coefficients randomly, because of which our calculation is completely wrong. And the way we calculate our calculation is again with some formula. You can use some formula to calculate error, you can use some other formula to calculate some error, and different kind of formulas are used on the basis of what exactly is the problem. Again, if you select model A, there can be formula A to find out the error. If you use model B, the problem can be different, and the way you find out the problem. But there are like 50-60 formulas in entire machine learning mathematical jargon. If we understand, that's great. If you don't understand, for now it's fine. Now, what do we do? That's more important. So consider this MSE formula. Let's suppose this is one formula. Let's forget about this cross entropy kind of error function. Let us consider an MSE, mean square error. If you are from some electrical engineering background, you might have heard this RSME, root mean square error, like RMSE, root mean square of AC current is some kind of a power of DC current or something. Let's not completely get into it. Let's ignore this. So let's focus on this diagram. This is a very interesting thing. You have three axes. You have some B's, and then you have J. J is on the vertical axis. That is your error. So the higher you are on this smooth surface, the higher is the error. And the lower you are on this surface, the lower is the error. So your objective is to reach to a point where you are at the lowest of the error, at the very lowest of this error. And at this point, the associated W and B, W1, W2, B1, B2, the associate numbers are the numbers that we want. Because if that was the configuration of our W1 and W2s, B1, B0, B1, B, and all those numbers, then our predictions will be very close to the actual thing. So how do we do that? It's very simple. If I drop a ball, in which direction the ball should go? Towards the direction of highest or steepest gradient. So if I if consider that there is a lot of fog, and I throw you out of an aircraft with a parachute, obviously, without, not without a parachute. If I throw you out of an aircraft with a parachute, and you randomly landed on some kind of a point on this curvature, and there is so much fog and you can't see what's going on around, what is the strategy to come down to the minima? You will move, you will look all around, one step all around, and you will take a step in the direction where you are finding that there is a slope, there is a gradient. And then again you will see, okay, next step, which is the direction, which is the next step where I can move and can reduce the slope, can reduce the height. So that's what we are doing right here. Kind of an analogy. We start from some random position, parachute drop. We find out what is the exact height. We do the calculation. We make some prediction. We find out our error, and then we make a step. And then we repeat this. We make another step. We make another step. We keep on making these steps so that eventually we reach at the bottom. That's what we are doing in machine learning. And this algorithm of eventually doing it step by step is known as gradient descent. So we use some kind of optimization algorithm to reduce the error by finding the right impact of W0, W1, W2, or B0, B1, B2. Just like switching your radio this way or that way. And if you get this hazy noise, then your brain says, okay, there is a big gadbad, there is a big mistake in the current configuration, and you change and you keep on listening to the audio over the period of time. You set it, and that radio is giving you the feedback, and then you get a very clear voice and you understand, okay, this is the right setting. So basically you are doing machine learning to configure that radio. Not machine learning, but exactly what you do there is what we are doing over here. Simple enough, not a big deal. If there is any question, let me know. I think this maybe is the last slide of mathematical aspect of it. Now, again, there are some simple models, there are some difficult models, there are some complex models. There are some simple problems, there are some difficult problems. There can be a model as simple as a straight line, a linear regression, a model as complicated as a 50 layer neural network. There is something called a ResNet kind of a convolutional network, which is very deep, very big. So according to the model that you have selected, you can have different formulas to calculate error. And according to the formulas that you have selected, you can have different surfaces. As simple as this smooth curvature on the top, and as difficult as this Himalayan ranges, the mountain Himalaya, the like kind of like Himalayan ranges kind of a thing. And now I drop you and you want to reach out to the lowest peak. And worst case, it can also be higher dimensions. So you may land up, you may have an error surface which is 50 dimensions of Himalayan surface. So it's just not 3 dimensions, but it's 50 dimensions of something which is moreover like. So you can't just don't try to imagine it. So complex models result in complex kind of error surfaces, and complex kind of error surfaces require complex kind of algorithms to solve it. But all working in the same strategy. One simple thing can be, that's the case, then we'll repeat the entire procedure multiple times. So one time we'll land in Tibet, sometime we'll land in Rishikesh, sometime we'll land in Rudraprayag, sometime we'll land in Devprayag or like Kedarnath or something, and we'll come out Garaos and we'll find out what is the right thing. So let's not get into it. That's what we do. We try to reduce the loss function, we try to reduce the error function, we try to come to the bottom of it. Again, in deep learning in AI, it is easier done than said. In real world, it is easier said than done, but here it is easier done than said. That's what engineers do. Mechanical engineering is very complicated. The way car works is very complicated, but it's easier to drive it. All you need to do is you need to push the throttle and the car will work. Similarly, with these powerful libraries like Python, we have a lot of, I mean, with these powerful libraries like languages like Python, which have a lot of libraries, where all these concepts are encapsulated, just like your engine is encapsulated inside the hood, and you don't need to understand how engine works. All you need to understand the gear, the speed box, and everything, and then you will be able to drive the car and will be able to win F1 racing. Similarly, to actually implement data science in real world business problems, you don't need to understand the mathematical prospect of it, or you need to understand, but you don't need to implement it. You have these very powerful languages, very powerful tools which encapsulates everything, and it's as simple as driving a car to understanding mechanical engineering. So we don't need to do it. It's just one line of code. Trust me, one line of code or like 10 lines of code, and you will be able to implement very complicated neural net and will be able to build quite an effective technology. Then over the period of time, if you want to, for example, if there is a new research paper in the market, and it just came yesterday, and you want to be one of the first people to implement it, there is no support in Python, you will have to do it. Or if there is no solution to it and you want to do research and you want to come up with a new machine learning algorithm, or you want to come up with a new improvement in some kind of machine learning, or if your problem is really hard and you are able to achieve 98%, you are able to achieve 98, 99%, but you want to achieve 99.9%, 99.98% accuracy, very, very effective accuracy. In that case, until you don't know the formulas, you will not be able to fine tune, you will tweak these formulas, you will understand the mechanical engineering from a very core perspective, and then you will be able to modify it according to your needs. So unless otherwise you are getting into that extreme domain of top 1%, top 2% data scientists who are actually doing research or kind of like getting the best of the best technology, which is kind of an advanced thing to begin with. To drive a car at 100 kilometers per hour, 150 kilometers per hour, which is something which will solve most of the purposes, it's quite a straightforward thing. Let's not get into all these things for now. That's what kind of things that people do. Now, this is the last slide that I'm going to show. And this is where the technology, the impact of this technology comes. Now you see that this machine learning model is trying to fit a line into the data which is non-linear in nature. So howsoever machine learning algorithms work, if your assumption is that there is a linear trend in the data and you want to fit a line into a non-linear symmetry, if you choose a wrong model, then your machine learning algorithm will not be able to give far better accuracy whatsoever you do. But then we have some kind of algorithms called neural networks, which are also able to learn this non-linearity in the data, this non-linear relationships. Now, this is a very significant thing, because once your model is by itself able to learn the factors, the weightages and also the factors, then it is basically kind of a universal function approximator. Basically speaking, you give any input, you give any output, it will be able to find out the nonlinear relationship. It will be able to find out the features inside it. You don't need to tell what exactly is the feature. In other terms, in other words, this diagram that you see, there are other techniques too to solve it, but what neural networks can do, let me go back to the entire procedure and tell you what neural networks do, so that you will be able to understand what exactly is the state of the art AI that we are dealing with right now. Now, we have these photographs, eagle and different kind of birds in front of us. Correct. These are the birds in front of us. We looked into these birds, and then we say that then there may be some features. Look into these birds. I just wanted to understand that this is not that straightforward problem. The photographs have a lot of variations. And then we come up with these features. Okay, wingspan can be something, this can be something, this can be something. And then we say that, okay, these are the factors over which we are going to make a decision. What if I say that I will simply give this photograph to the algorithm? I'll not tell whether it is the wingspan or whether it is the beak or whether it is the size or whether it is, I'm not going to tell the features, neither the weights nor the features. I'll simply say that there may be 10 features. I don't know what those features are, but you, my friend, by yourself find out what are those features. Now, that is a revolutionary technique that's very, very powerful. All I am doing is I am simply giving unstructured data to my algorithm and saying, look, this is the garbage input and I want this output, and you do whatever is required to work around it. Now, garbage, you need some pre-processing. We'll come to that in a moment, but this is a representation of neural network, just a diagram, like a very kind of fancy diagram, uh, which is basically 4 line of code. What you are doing, you take data, which is your input, and you give the output, that this is the input, this is the output. This is one way you can use neural network. We can also use neural network as unsupervised learning. We can also use it for some hidden representation clustering, which we are not going to discuss it today. But for now, we said this is the input, this is the output. We don't know what exactly is the relationship. We don't know whether it is wingspan or size or color. I don't know. You find it out by yourself. So in this case, there are like 1, 2, 3, 4, 5, 6, 7 features. First hidden layer has 7 features. So there may be some 7 features, some basic 7 features. You find it out by yourself, and using those 7 features, again find out some more complicated 7 features. Find out 7. What 7? I don't know. I'll simply tell 7, 8, 10, 15, and then give me the output. Now this is very, very complicated and very, very powerful. What I can do, in principle, let's not get into how it is done, but what we can do is something that you understand. You record this video. You record, this is the power of this technology. You record this video and record it for like 10, 15, 20 hours. You take my face while I'm speaking. You extract the audio out of this, and when you extract the audio out of this, you will get a video where I'm speaking, where my lips are moving, and then you have audio where actually the sound was produced because I'm speaking something. So you consider this video where my lips were moving as input, and the audio which was the output. Say that for this input, this was the output. There is some kind of a hidden relationship between input and output. I don't know. You learn it by yourself. And by doing so, you are giving this neural network a task to actually read lips. If you do so, next time I come and I'll simply sit down and I move my lips, I speak anything, this neural network will be able to read my lips and will be able to generate an audio. How do you generate an audio? How do you encrypt those numbers back to some audio is something else, but it will be able to find out that exact relationship between lip movement and the audio which is generated. with sufficient data. In principle, this can be done. There are so many things that you need to do before. For example, you need to do facial key point extracts, and then you need to pre-process it. Just like you extract crude oil from earth, but you don't put crude oil in your car to run it. You will like refine it. You will process it so that it becomes petroleum, it becomes gasoline, it becomes diesel, and then you put it into your car. You just don't take your data like crude and put it into a machine learning model. You need to do some pre-processing, which is a major task, so that it comes in some kind of a shape or a form that these algorithms can understand, and then you can put it. But in principle, these are so powerful things. These are so powerful things that this is a one-stop solution for many problems. One-stop solution. The reason being, you are not doing feature engineering. So if you don't actually understand the problem, you don't understand exactly what makes an email spam or not spam. You simply give the data saying this is spam, this is not spam. You find the relationship. I don't care. You are my universal function approximator. I am not doing feature engineering for you. Human beings are not doing. That's something which is done by these neural networks if you have sufficient data and then sufficient pre-processing. It is such a powerful technology that this is a one-stop solution for many problems. If you see this video, this slide, there are so many use cases in one particular application of deep learning, which is computer vision, from object tracking to real-time human pose estimation to a lot of things, which are the state-of-the-art technology in many commercial applications. We'll look into some of them. If you look into this diagram, again, from sentiment analysis to language translations to all other things, basically the same thing, neural network, deep learning. Let's take them case by case. But before that, this self-driven car, same thing. How it's happening. One example now. Let me explain how this is working. The way I'm explaining is far simplified case of the real sense, because I cannot explain reinforcement learning in the right way, because it will be a difficult topic to explain, and it is a difficult topic for me to understand too for now. So I'm not really good into reinforcement learning as of now. I can build things, but I'm not like very strong in that. So I'll simplify this, and I'll tell what exactly is going on. So the driver is sitting in the car. Again, this is not the right thing. So I'm just trying to explain the power of deep learning from that perspective. I'm telling you, the driver is sitting in the car. Then whatever he's controlling in the car, the steering and the gear and the brake and everything, is the output that we want, the desired output that we want over the input, which is calculated by a lot of sensors, distance sensors, cameras, and all kind of things. All kind of sensors. The more you put, the better it is. Now, this driver is going to sit in the car and will start to drive the car. Will start to drive the car, and over the period of time, we have this input-output data, that if this was the input, this was the output, this was the input, this was the output, and then we'll give this data to the model and say that, okay, we don't know what is the relationship between input and output, but you find it out. And in principle, that neural network can actually find out the relationship between what we as human beings get as an input from our eyes and ears, from our sensory from our senses, and how we reacted in that car. So that's how you can in principle build a self-driven car. uh, this is not created, self-driven cars are not built in this way because we don't have that much big data. So this is done in a simulation where the car, nobody is driving the car, there is no data as such, and the car is doing some random things, and it hits things, and there are some penalties and all kind of things. And over the period of time in that simulation, in that game, the computer by itself learns over the period of time. So basically, if you see this combinatorics which we discussed so far, so you're using a deep learning with a genetic algorithm to perform some kind of reinforcement learning, which basically happens over the period of time in evolution. So using genetic algorithms, you're using something called neural topological search, all kind of things. You use something called q learning, where you don't have the data, but you have a simulation, and the computer plays that game into that simulation, and over the period of time, with reward and with penalties, it learns a behavior. So slightly complicated, but very powerful technologies can be developed. But again, the core of self reinforcement learning is also the deep neural networks. It's also a subset of deep learning. Self driven cars. Let's talk about some top tech around and how basically deep learning is revolutionizing everything. So if I talk about Siri, there are so many things into a chatbot, whether it is Siri or Google Assistant. But one important task that it needs to do is natural language processing. That is understanding the natural language understanding, and generating the natural language generation. There is a buzz going in the market called ChatGPT, which is basically working in NLG. Now, whatever I say, for example, if you recognize the same thing, I was sitting near the bank or I went to a bank to get some money. Whatever I say to Siri, for example, book me a ticket from Indore to New Delhi 3 days from now, or what is the temperature in New Delhi today. To actually respond, first of all, Siri have to understand the intention. Two sentences have two different intentions. So first, Siri needs to do an intent classification. And then book me a ticket from Indore to New Delhi 3 days from now. So from Indore to Delhi, these are two information. 3 days from now, so now is the information. 3 days is the information. So it needs to extract some. It needs to recognize some entities to fulfill that intention. So intent classification and entity recognition are two very important natural language processing tasks that we need to build. Again, we use deep learning to do that. How do we do that? We have a lot of messages written by human beings, and we say that we label the data. We build this data set by ourselves. For this message, this is the intention. For this message, this is the intention. For this message, this is the intention. And now, my friend neural network, you find out what is the relation, what makes this message intention one, what makes this message intention two. You do the intent classification by yourself. We are not writing down a procedure to tell, or we are not writing an algorithm, we are not hard coding the logic to classify this is done by uh, machine itself, neural network itself. Very powerful. I take Chinese, and I take a Chinese message, convert it into Japanese. I found an expert. I have 50,000, 500,000, or 5 million, forget about the numbers. I have a lot of Chinese messages, and I have a lot of translated Japanese messages. So this is Chinese, this is Japanese, or like English to Hindi or any other language, German to Spanish. I say to neural network that this Chinese message is the input and this Japanese message is the output. Now, I don't know Chinese language, I don't know Japanese language, I don't know anything about it. You do get into this, you understand the features. Basically, I am saying you understand the grammar, you understand the entire linguistic of these languages, which were developed over 5,000 years. I don't care. And then you find out this hidden relationship between input and output. And I'll give you a message in Chinese, you give me an output. Magical. Mathematics. What would you say? Mathematics and magic. Language translation. Same neural network which was doing intent classification, same neural network which was doing language translation, and same neural network technology is also giving you right recognition, like right video ranking. With all these things, your previous history and everything, YouTube also understands. If you see this video extraction step, YouTube also understand what's going on in the video. So YouTube's deep learning algorithms can actually process videos just like human beings can analyze what's going on. Now, camera is just like an eye see, brain process. Similarly, camera see, but you require technology, you require computation, we require something to process it. So you are using the same deep learning algorithm which you use for language translation for also doing some kind of video processing and extracting information, understanding what that video is. One solution for many problems. Document automation. You give a handwritten document, get a PDF. You give some images, you give some invoices, you extract everything into some kind of an Excel sheet. uh, you give a big document, and that's machine comprehension. But basically in machine comprehension, you give a document, you give a question, and you want an answer. You give uh, uh, big sentence and you want a small sentence. You give a paragraph, you want to have a summary. You give sentence, you find the sentiment. Same thing. Neural network, deep learning. Many problems, one solution. Face recognition in Facebook, or like in any face in your iPhone, which can recognize. iPhone is even smarter. iPhone don't recognize your face. iPhone create a 3D map of your face, so that even you open your iPhone in darkness, it actually creates it has a lidar camera, a very small lidar camera. It creates a 3D mapping. So instead of simply looking into a photograph, it actually creates a 3D structure and can far better accuracy figure out who it is. But basically, even if it is face recognition in phone technology or anything, same thing. This is you give your 5 6 10 examples. They use something called transfer learning, but you give 5 6 10 examples. You put your finger for a few times and say, okay, you put your finger, you put your few thumb, you put your thumb again, you put your thumb again 4 5 6 times, and they understand, okay, it's your thumb. And then neural networks can recognize your thumb or your face or anything else, biometric systems. One problem, I mean many problems, one solution. Intelligence is that this is narrow AI. This is narrow. So the neural network, which can classify whether there is brain cancer or not into one image, cannot do anything other than classifying whether there is brain cancer or not in this MRI image to a superhuman expertise level. So that's one problem, because it is hard for us to train it. So that's why we call, for example, if a neural network uh, can do voice recognition, then you can use it in Alexa. You say, Alexa, turn off the lights. So when you say Alexa, turn off the lights, it converts it into linguistics, and then I mean voice to text, and then the text gets classified. So that model which can transform from voice to text is again another neural network, but it can do only that thing. It cannot do anything else. A neural network which can drive a car can only drive a car. It cannot figure out whether it is a burger or a sandwich. And a neural network which can classify it is a burger or a sandwich cannot classify it is dog or cat. It is narrow. We are in the age of narrow AI. We are not in the age of general AI. This is not the age of AGI, at least for now, artificial general intelligence. Once we have artificial general intelligence, things will change a lot of time. It's not something which is new in computer science. In initial times, when Charles Babbage created the first difference engine, when he created the computers were also same. For one problem, it requires some kind of hardware. If you want your computer to do something else, you want to change your hardware. So if you want your computer to perform Photoshop, you need to change the hardware. If you want your computer to work on Teams and deliver this session, you need to change the hardware. So we wanted a universal computers. We wanted a universal Turing machine, which basically is our computers, a electronic universal Turing machine. So over the period of time, we created a system where the computers can do all the tasks. We don't need to change the hardware. So one breakthrough will bring artificial general intelligence too, and then AGI will come. I am sorry I was not able to add a slide, but artificial general intelligence will be very powerful thing. There are few other things. AGI, I believe, is slightly ahead. It's not that near. Is slightly ahead. I think we'll need to work for next 10-20 years to actually reach to the age of AGI, or 25 years to actually reach to the age of AGI. But still, there are a few very powerful technologies which are going in the market, and which may be, to some extent, they are reality even today, and they may manifest to very powerful thing in next 2 3 5 years. So I would like to tell you that this small boy is actually controlling this robotic arm through his mind. So he's thinking to control this arm, and he is able to do so. Uh, this is again was possible because of deep learning. So the device that he is wearing on his head is called OpenBCI, Open Brain Computer Interface. This is a 70,000 device. If I was in my office, I would have shown this device to you. It is basically the open source version of Neuralink that Elon Musk wants to create. He wants to create a small chip that you can implant in your mind, and you know that all your uh, mind is an electromagnetic device. There is a lot of it's not electrochemical device, but it has brain waves, it has some electromagnetic waves. That's why we say that don't sleep in north pole direction or something. There may be some, it's not, I don't know whether that is true or false, but it is for sure a truth that brain releases brain waves. That's why we are able to do MRI, magnetic response imaging, something like this. But what actually happens uh, when we capture those brain waves, brain signals, it's kind of a cocktail party problem. It's like every one of us starts to speak right now and we record this, and then I go home, like I end the session and I want to understand what exactly one guy was saying, because there was so much noise. We are in a party and everybody is speaking, and I want to find out that one signal, that one voice. It's difficult. So when you are thinking to control that hand, your brain is just not thinking to control that hand. This boy's brain is just not thinking to control the hand. This boy is doing a lot of things. His brain is doing a lot of things. For example, he's breathing. For example, his brain is also maintaining his body temperature, his heartbeat, all the vital medical things. His brain is also instructing his pancreas to create insulin so that he don't get it diabetes. uh, all other kind of biological features. Just like your brain is listening to me, and your brain is also thinking how much time he is also going to take to complete this session. You are doing all kind of things, you are also focusing. And so all those signals when you capture, it's kind of bizarre, it's kind of cocktail party problem. Now how do we extract that one signal from the many signals is something you require a lot of feature engineering, and such kind of intense signal processing was not possible without the neural networks. So this brain computer interface with 10 lines, 15 lines, 20 lines, maybe 100 lines of Python code and 70,000 rupees open BCI kit, you are able to build a technology where you can technically connect your brain to uh, the computer, and then you can build whatever you want. Sky is the limit. This is a quantum computer, and I tell you, this is there. You can use quantum computers for some kind of research things. You can host a quantum computer on IBM Quantum, basically free of cost, or like nothing, and then you can implement some nitty gritty small things. But very soon, I mean, maybe next month, maybe 1 year, maybe 2 year, maybe 5 years down the line, we will be having the first business level quantum computer, like quantum computers for business applications. And then you think that, oh, they're very costly, we don't, it won't work like this. You will be able to host a quantum computer over the cloud on AWS or Azure or on GCP, just like you are hosting EC2 instances for few seconds, for few minutes, for few hours at a very affordable cost, pay per use. And then you will be able to use quantum computing for business applications. So imagine the power of deep learning which we have. Imagine the kind of I'm not talking about AGI, forget about AGI, but imagine the deep learning capabilities we have, and imagine the quantum computers that we are going to come in next 5-10 years. What kind of a transformation we are going to get by 2047, 2050. Our sense of development that we are talking about, that India should be developed by 2047, has to incur this great technological change. Otherwise our sense of development, what we perceive as development, will be outdated. So by 2047 the definition of development will change, and we need to realize, we need to recognize, and we need to spread this awareness that in next 25 years the world is going to change. It's an Amrit Mahotsav for the entire world if the technology breaks things the way we want. The next breakthrough is the game changer. One more area where we are using deep learning a lot is computational genomics. We are not able to understand human DNA data so easily, but now you don't need to do feature engineering. So you can use a neural network, some kind of biology, genetics, and then you can extract the critical information. You can do all kind of things to create some gene therapies for a lot of medical problems. So imagine AGI is coming down the line. computational genomics, where you can genetically engineer human beings, brain computer interfaces, quantum computing. In next 20-25 years, the world is going to be transformed completely. In next 25 years, the world is going to be a completely different place, which many of us are not able to comprehend. And this is a very powerful thing, and this is a disruption too. Let's not talk about that far. Let's see what's going on. Let's not talk about this is the future, what's going to happen tomorrow. Let's see what was there in the market for last 10 years, what's going on right now. So let's talk about the disruption in industry which is going on right now. So this, you see 2012 on this chart, was the year where there was this breakthrough by Professor Jeffrey Hinton, University of Toronto. And then from 2011 to 2016, you can see an exponential increase in the investment in AI research. And till 2022, we don't know. And again, one breakthrough got this. There were many more breakthroughs over the period of time. Chat GPT is one such breakthrough, which recently happened. If you look into these industries, almost like this is something that very obviously, very honestly, I took a screenshot from Google, but almost all the industries are getting transformed by artificial intelligence, and specifically because of deep learning. If I talk about the Asia Pacific AI market, 2020, it is 12 point Asia. I'm not talking about the global market. 2020, it is $12.9 billion. 2030, it is exponential. I don't know. It's like Asia Pacific market for AI is going to be AI, basically deep learning, is going to be 180. It is a transformation. It is a disruptive one, and we need to understand that we need to ride this wave correctly. Businesses will have to ride this wave correctly because there are challenges. There are many, but I'm talking about three challenges. I'm not talking about challenges from a humanitarian perspective, whether it is good or wrong. I will also say that technology is like fire. You can use fire to protect your family when your ancestors were living in cave from wild animals. Even today, when you go to jungle, the fire is the protector in the night, and you can use same fire to burn a living person or burn someone's house. So fire is not right or wrong. So if you have any kind of a moral ethic, whether AI is good or bad, AI is not good or bad. It is technology. It is the person who use it correctly or not. So it's not the role of scientists to consider whether technology is good or bad. It is the role of law enforcement authorities to make right regulations and enforce laws in a way that data privacy and the entire moral human aspects are maintained. So if AI becomes an evil, it's not the AI's fault, it's not the scientists' fault. It's the job of law enforcement to make sure that people use technology correctly. You have a gun, you have a gun basically so that when you go to jungle, or when a farmer go to a jungle and live animal come, a wild animal come, he can protect himself. Or like you have a gun so that Ajmal Kasab hits Mumbai, you can save yourself. uh, but you can give a gun to Ajmal Kasab and then he can kill people. So it's the job of government to enforce regulations to get a license to get a gun. Gun is not right or wrong, it is the person who is using it. So let's cut the moral things. From a business perspective, there are a lot of challenges. First, there's so many, but the first is that technology is moving very fast. And this rapidly changing technology will put our investments on risk. So, what our current solutions, what we consider are marketable, what we consider are really good state of the art, may become obsolete next year because technology is moving so fast. What is best today may not be best tomorrow. So we need to have continuous improvement. We need to have continuous innovation. It cannot be like we are best in the market today, we'll be best tomorrow. And uh, with big organizations, there is a problem. There is a very fundamental problem. When the organization is small, the only way to make money and grow is innovation. But when you grow, when you become big, when you become IBM of some time, then you have monopoly in the market. And when you have monopoly in the market, you are the biggest seller in the market. The amount of innovation you do will not reflect directly on sales because you are already selling the best technology. So the only way to make business even larger and make profitable and grow and survive is when companies become big, they shift themselves from innovation to sales. And this is a mistake, because then Apple comes and they create a completely new personal computing space and have a bigger market share. This was in the age of silicon era. In artificial intelligence, technology is running, if not flying. And even we are creating monopolies in the market, the innovation has to be thing, because technological disruption, rapidly changing technology is the biggest monopoly barrier. So this is something that we need to understand. Second, with this, the gap between big and small is really low. So a breakthrough 5 days before is a breakthrough for a big R&D house and also for a 3 people startup. If chat gpt is in the market, other than OpenAI, if it is in the market for big companies, it is open in the market for small companies too. So you'll find out that a lot of new unicorns, a lot of new competition of all kind will emerge in the market. And the spaces where we are into, our businesses are into, will find much more competition. So these are two major challenges, and because of these two challenges, it is very much necessary for us to perform this workforce transformation. Now, the challenge with workforce transformation is you cannot train your AI experts everything. You cannot train your AI experts audit and retail and communication and aviation and preventive maintenance of bullet trains and construction and ERP solutions and SAP solutions and SAP consulting and business solutions and all. You cannot train your AI engineers everything. If your AI engineer don't know aeronautics, how can he build a technology for aeronautics engineering? So you just have two options. We just have two options. Either we hire super smart AI engineers and train our AI engineers everything that we do, or we hire the same quality of AI engineers, but we train our artificial intelligence to everyone that we have in our organizations, not to a level that they can implement, but to a level that they can find out use cases in their own business domains. So what we believe is this cross domain adoption is necessary, because if somebody is working in SAP consulting, he needs to understand machine learning, deep learning to some extent, that he can go to his business specifications, his subject matter expertise, and can come up with areas where he think there is a problem, and this is how AI and this is how deep learning can solve it. So he needs to understand the true capabilities of technology, and then he will be able to answer the what is something that we which is not solved in his subject, is his area, and what is that thing that we can work. How to do that is your AI team's work. But you need to understand that SAP consulting people also needs to understand deep learning to such an extent, or audit people, the chartered accountants needs to understand deep learning to some extent, so that they can find out and say, okay, these are the areas where I think there are some possibilities, because I know how technology works. And then the AI teams, the technology teams and business people can come down and can create some solutions. So that's what we need to do, the cross domain adoption and learning. So you have this core AI team, you require them, but you cannot rely on them, you cannot work without them. You also need to have your business people, and they both come together to create this hybrid team, and then you can work with those agile environment and everything that you want to do, and can generate some results. I believe that there should be 4 steps. First is awareness. We need to conduct awareness programs, 1 day awareness programs, or like 2 hours awareness program to business people, so that we reach out and we tell what exactly is going on in the market. Once the awareness is done, we can teams where dedicated learning can be there. Now this dedicated learning can be in house, where you use your own people to train it, or this dedicated learning can be outsource where we as your learning partner can come and deliver some things to you. Both options are open to you. We as businesses would like to definitely serve you, but from a pure engineering consulting perspective, both options are open to you. Third is you find some use cases and build some minimal viable products. This is something that can be created with open source technologies within a week or 10 days or 15 days if the teams are good. And then some business feasibility, for example, net present value of an MVP can be calculated, the feasibility can be calculated, and with this all MVPs and all different areas that we look into, we can come up with a few solutions that we think are marketable and good enough, and we can allocate a bigger resource in terms of human capital and financing to build technologies, build solutions, build services, build products that we can market next year or 1.5 years down the line. So 4-step mechanism is something that I really suggest. Now, from a pure engineering perspective, I'm also showing you what I think is a straightforward way. So if somebody wants to do a self-learning, just simply do 50 questions in Python, basic questions. You don't need to become a super smart software engineer. And then go to some medium articles on internet and implement these machine learning libraries. Few things you have started in machine learning. You will understand because these blogs are self-explanatory. They will explain the concept and you will, in the easiest way, will be able to understand something. So this will give you the top-down approach where you have your hands dirty. So this is the first thing you need to do. Once you have your hands dirty into the machine learning kind of a thing, then you need to have some kind of systematic learning. Don't do systematic learning initially because then it is going to be boring. But don't simply get your hand dirty and have no systematic learning. After this, you should be, so this can be one day where you implement like few programs if the people are programming, or like for 2 days or 3 days or whatever be. Then get into statistics. The course which I have done, I have mentioned. There are so many courses on statistics. The core statistics hypothesis testing, which is an engineering statistics subject. So many online courses are there. And, then Essence of Linear Algebra is a very beautiful course by some guy called Three Blue One Brown on YouTube. Like it's take 4 or 5 hours to actually. Now linear algebra is a big subject, but we don't need to teach entire. I've done all many studies, researches while I was learning. Again, I know very few things in it, but this is a good thing. Then you need to understand. So, for example, we understood one machine learning. This is something that you, if you really wish to go to that level, you need to do. Otherwise, first two are okay. Then this data analytics by MIT EDX is very powerful thing. Because once your statistics is done, then this analytics course will give you a lot of understanding, and then you will be able to implement some case studies. And now this is significant deep machine learning path. And then if you want, you can actually go through this really great course, per.ai by Professor Mithilesh Kapra, IIT Madras. He has a course on NPTEL, which is very brilliant but highly mathematical. But this is a very powerful course, and I have gone through a lot of courses, but I recommend this is one of the best. And the last one is, if you want to get into all those 6 pillars of AI that we discussed, then this Stanford CS221 is something that you can go with. So this is an open path. Now we have gone through this path with our years of work, with very limited humble knowledge that we have on this field. But we have been doing this for last years because we are startups. We are like kind of doing things, build technology 10 years down the line. And over the period of time, we understand we've gone through this and we have developed some subject matter expertise. And then I have been training and delivering this over the period of time. So you can go through this open source, or we can come as corporate trainers and can deliver either the entire thing or some sub segment of it in a very time efficient and very speedy manner, because we have gone through that journey and we know what needs to be taken care of, what not to be taken care of. So we can speed up this, we can act as a catalyst into the reaction of human development and learning into the field of AI. So that can actually save a lot of time, because your employees will be saving a lot of time, to learn a lot of things, and then will reduce down the opportunity cost, and you will be able to use them in some other things. So a lot of benefit if some really strong corporate trainers, some really strong training companies work with the L&D and deliver this thing in a very practical and efficient way. If the people know what they are talking about, if people know how it is done, then it is a profitable thing, because from the sheer perspective of opportunity cost, and also the effectiveness of learning and everything is also there, that everybody is more about it. This is moreover like if somebody really wants to stay up to date, you can take a screenshot of this and just follow them on Twitter. Follow them on Twitter, then Twitter will give you a lot of AI researchers, and your Twitter feed will become AI feed. You will be it will be news feed of artificial intelligence. So you will be up to date. So with this static learning, where you will require us if you don't want to, this will keep you up to date. General awareness, like the general knowledge what's going on, and this is very effective because you always stay up to date. So if we implement uh, some trainings with you, we have everything open source. We will be providing you GPUs free of cost, Google Colab. We will be working on open source libraries. We will be using a lot of open source data that we have, starting from like Coco, millions of images. Then we have parliamentary proceedings. We have all kind of data sets. Some of them I mentioned. We have a lot of pre-trained models like YOLO, POC is implementing something in the case study. So this corporate learning also becomes some kind of a very initial crude MVP aspect, and we can do some market feasibility and all those things. So this is what I wanted to share. Thank you very much. Again, my name is Shivang Trivedi. I am a learner of this field. I know a few things, but this is a big science, and uh, I would be glad if you give me an opportunity to help with you. We will be able to take care of a lot of things from our side. Again, this is a big thing, and this is high time that we as companies take the initiative and get into it. I'll open down for questions if any. Let me also see if you guys have a few questions. Okay. Thanks for the session. Great. Let me know if you have some questions. I am here. And somebody from our team can take on from now. Sugandhi, are you there? Roshan? Mm, let me just give a quick call so that somebody from Roshan or
Yeah, Shivam.
okay, you're there.
Kumar
Great.
here.
Oh, great.
I guess participants will be not having any questions. If they have, they can ask. Thank you everyone for joining this session. I would especially thank Mr. Shivam for sharing more knowledge on artificial intelligence and deep learning. We're requesting you to fill the feedback form for this session. I have shared in the chat box.
There is a question. Could you please define the intercept in this context? Uh, DV can you explain this to me? For example, I'm not able to grasp.
No worries, Shivang. So, I asked this question when you were presenting dependent variable and independent variable, a linear graph.
Hmm.
So, in that one, in that particular linear equation, y was equivalent to b naught plus b1 x1, where b1
Correct.
weights and x1 the features
Features.
that you have extracted, right? So,
Correct.
you in very layman language explain the significance of B1 and X1 and so on. But what exactly the B naught, the
Ah,
intercept, yeah,
so
define.
sometimes what happens is even if all your features are zero, not necessarily the output is zero. For example, if I consider that salary of a person in a company is dependent on a lot of things. For example, his years of experience, his qualification, his age, his region, his past salary, his college, all kind of things. Salary is dependent on something. But let's suppose that somebody who's not educated, who has no experience at all, who has no salary before, all the features are almost zero. Still, it doesn't mean that when he get into a job, his first job will give him zero salary. So what if in a case when x1, x2, x3, they all end up being zero, but still there may be a chance of output getting some positive or negative value. So that is the bias term, that is the intercept term that we give. Otherwise, if all the features which are important to figure out the salary of a person are zero, it will always, whatever the numbers of b1, b2, b3, b4, b10 you learn, if your x's are all the time zero, then your salary, the output salary, will always be zero, which cannot be the real representation of a business case. That's why you also need to learn another term, b0, the intercept, the bias term, where every factor related to salaries are zero, but still there may be a marginal 5,000-6,000 salaries which is there. This is one example, but you can use it in any other term possible. So we keep that, and we keep that bias term for a model, that if there is no intercept requirement, set it to zero, or set it to negative, or set it to something if required. Just like there are so many factors that are necessary to pass an exam. How much number of hours you studied, or how much number of what was your past score and everything like that. But even if somebody goes for an exam with all those prerequisites as zero, he may come up and he may solve some questions by mistake, some random talks, or like, I mean, some random multiple choice questions, or maybe just he wrote something and he got half a mark or 1 mark. So there may be some scenario to represent that. These are two examples which are much more like normal in nature. This is all the where in real worlds. That's why we need that bias term.
Got it. Got it. Thank you.
Okay. Sure. Okay, great. Thank you, everyone. It was nice meeting you.
Thank you.
Thanks, Shivam.
Thanks, Shivam.
Thank you.
Yeah.
Shivam.
Thank you.
Once again, thank you everyone for joining this session. Have a great evening.
Thank you.